In this video, we're going to look at how to multiply using a grid. Now, our first example we've got here is 43 times 6. Now, if you're of a slightly older generation like myself, you probably look at that and you go, all right, well, what I'm going to do is 43 times by 6, and I need to do what's known as a chimney sum or a tower sum or a stack sum. And you'd go, right, well, 6 times 3 is 18, so 1, 8, because I have to carry that 1 over. 6 times 4 is 24, add the 1 is 25, and the answer is 258. Now, that is all very well and good, but we've got floating numbers all over the place. And although it was kind of drilled into many of us at a very early age how to work with these, when we get to harder examples later on, it is handy to have a method that works for every example that you're going to look at, okay? So the grid method does things slightly differently. What it does is it looks at the fact we've got our tens and our units column, or tens and ones column, depending on the teacher that's taking you through the work, okay? So we're going to make a wee grid, like so. We're going to split 43 up into 40, add 3. So I'm going to write this at the top of my grid, 40 and plus 3. And at the side, I'm going to put down my 6. I'm going to split this into two different calculations. What I'm going to do first of all is work out what 6 times 40 is. Then I'm going to work out what 6 times 3 is. I'm going to add the two numbers together. So 6 times 40, well, 6 times 4 would be 24. So 6 times 40 would be 240. Meanwhile, 6 times 3 is 18. And all I'm going to do is add the two values together. So I've got 240 plus 18 gives me 258. Okay. So we move on to a slightly harder example. And again, some of you of the old generations might look at this and go, right, well, that's 74 times 23. Do a big long multiplication sum like so. The first row would be 3 times 74. The second row would be 20 times 74. And then you add the two values together at the end. Now, again, the issue that we've got here is that you're going to have floating numbers all over the place when you start carrying things all over. So 3 times 4 is 12, you carry a 1, 3 times 7 is 21, plus 1 is 22. Times in by something in the tens column, we put a 0 there. 2 times 4 is 8, 2 times 7 is 14, but we've still got this little floating 1 here. And for those people that maybe have issues with dyslexia, this is quite an unfriendly sort of thing to have in here, because although to the trained eye, this looks really intuitive, it's 222, for some folk, they might get confused as to what that 1 physically represents, okay? Sorry, I can't leave something uncompleted. So 2 plus 0 is 2, 2 plus 8 is 10, 2 plus 4 plus 1 is 7, so 1,702. So that's what we're aiming for. We're going to split this up the same way then. So 74, I can say, has been 70 plus 4. Meanwhile, 23 is 20 plus 3. So I'm going to make my grid again. I'm going to have 70 plus 4. I'm going to have 20 and plus 3. Right, each bit is going to be the multiplier of the two, the column and the row together. So this one here, for example, it's going to be 20 times 70. Well, 2 times 7 would be 14. So 20 times 7 would be 140. So 20 times 70 must be 1,400. Or if you like, a very quick way of looking at that is 2 times 7 is 14, 2 zeros in the question, 2 zeros in the answer, okay? Don't tell your maths teacher I said that. Next one, 20 times 4. Well, 2 times 4 is 8, 1 0, 1 0, okay? 70 times 3, 7 3s are 21, 1 0 at the end. And 3 times 4 is 12. And just as in the previous example where we just added the two numbers together, I now have 4 numbers to add together. So I've got 1,400, I have got 210, I have 80, and I have 12. And notice how I'm using the place value to line everything up. So I put all my units together, all my tens together, all my hundreds together, and thousands, okay? That gives me 2. 1 plus 8 plus 1 is 10. Carry 1 up here. 1 plus 4 plus 2 is 7. And 1 on its own, 1,702. Same as we've got over here. Okay? Right, a third one. Give this a go for yourself to begin with. See if you can use the grid method to split it up. I'll give you, maybe pause the video and try it for yourself. Okay, so what we're going to do here, rather than using our long multiplication, we're just going to go straight to the grid. So in the last one we had 74, so we had 70 plus 4. So in this one, we're going to have 50 plus 7. In the previous one we had 20 plus 3, so 20 plus 3. In this one we've got 89, so it's going to be 80 and 9. I'm going to work out these four values and add them together. 8 times 5 is 40. So 80 times 5 would be 400. So 80 times 50 would be 4,000. Or if you want, 8 times 5 is 40 and 2 extra zeros in the end. 80 times 7, well 8 sevens is 56. So 80 times 7 would be 560. 5 times 9 is 45. 1 0 in the end, 450. And 9 times 7 is 63. And let's add these four numbers together. So 4,560. 450 and 63. Add them all up. 3, 6 plus 6 is 12 plus 7. So plus 5, sorry, will be 17. Carry the 1 up. So 1 plus 0 plus 5 plus 4 is 10. And 1 plus 4 is 5. So answer 5,073. Okay. Let's try another one. Now, it doesn't matter whether we're dealing with integer values, so whole number values, or if we're dealing with decimals. The same principle applies. Okay, what we're going to do with this one, we've got 4.6 times 7.2. Now, I can imagine that as being 46 tenths. I can imagine that as being 72 tenths. Okay, so what I'm going to do with this, first of all, I'm going to rewrite this as being 46 tenths times 72 tenths. And when we're multiplying two fractions together, it's just top times top, bottom times bottom. Well, the bottom bit's fairly easy, I'm hoping. 10 times 10 is 100. And we should know by now how to multiply or divide by 100. The hard bit's going to be the 46 times 72. So we'll just do it here. 46 times 72 with my grid method. I've got 40 plus 6. I've got 70 and plus 2. 7 fours are 28, 1 2 zeros, 7 times 6 is 42 with 1 0 extra, 2 times 40 is 80, and 2 times 6 is 12. Add these together, 2,800, 420, 80 and 12, add them up, 0 0 0 2, 2 8 is 10, plus 1 is 11, carry 1 up. 1 plus 8 is 9, plus 4 is 13, and 1 plus 2 is 3. So 3,312. So that number here is what 46 times 72 is. So that's 3,312. Okay, now 3,312, if I imagine this decimal point there, if I divide by 100, all these digits here move 2 places to the right of the decimal point. So I would end up with 33.12. Now think about this logically. This is roughly, if we round that up, that's about 5, that's about 7. 5 times 7 would be roughly 35. That's roughly in the ballpark of 35. So we know that our answer must be correct. What a lot of teachers do also say to pupils is, well, if you do 46 times 72 and work out your 3312, I've got 2 decimal places in the question, so my answer must also have 2 decimal places in my answer, okay? There's 2 decimal places there. Let's try one more then. We've got 0.82 times 1.7. So what we did in the last one, we just imagined it as being 46 times 72. We'll do that here as well. We're going to do 82 times 17. So at the side, 82 times 17. With my grid, that's 80 plus 2. I've got 10 plus 7 going down the side. 10 times 80, 800. 10 times 2 is 20. 8 times 7 is 56, so 80 times 7 would be 560. And 7 times 2 is 14. I'm going to add the 4 numbers together, so 800, 560, 20, and 14. 0 plus 0 plus 0 is 4 is 4. 6 plus 2 plus 1 is 9. 8 plus 5 is 13. So I've got 1,394. So I know it's going to involve those numbers. 1,394. Now what we said in the last question was we've got 1, 2 decimal places in the question, so 2 decimal places in my answer. We can do the same with this one then, but this time it's not 2 decimal places we've got in the question. We've got 2 here and 1 here, so I've got 3 decimal places in my answer. There's 3 decimal places in the question, so 3 in my answer. So where would my decimal point go? Well, I want to position my decimal point so I'll have 3 digits afterwards. If I position it here, there are no digits afterwards. If I position it here, it's only 1 digit. Here is 2 digits, so it must be here. Just that point there, 3 digits after the decimal point. So 1.394. Okay. Give some a go for yourself, and if you get any questions, let me know. Thanks.